Okay, picking up where we left off on page 298, we're talking about using a graphics tablet on a traditional PC that doesn't have a touch sensitive screen. Okay, so next thing we're going to talk about is these motion inputs. And so, yeah, in addition to having a traditional mouse, you also have things like the Kinect from Microsoft, where it actually has like a video camera and you can make gestures in the air and it'll do something. You know, you can have one of these set up on your PC and you can do like that to double click something, for example, or you can move your hand around or whatever. You can orchestrate and do all sorts of crazy things with your hands, and it works pretty cool. That way you don't have to be physically close to the screen to be able to have your touch input actually happen, because you're not actually touching anything. You know, you're just waving in the air. So Wii game console was one of the first that came out with that. A lot of other game consoles jumped in. So air gestures are pretty doggone cool. Now you might think about this for just a minute. Let's say that you're a surgeon and you're in a surgical theater and you want to be able to view X-rays up on the screen while you're doing surgery. Do I want to touch anything with my gloves? You know, do I want to reach over and touch a button or a mouse and then go back to my patient? Is that what I want to do? Probably not, huh? So what don't you have to think? Air gestures would be pretty cool. You know, you have a monitor showing the X-ray and you do this to mean go to the next screen, or you do this to mean zoom in. You know, just gestures in the air. Pretty cool, huh? Okay, so it's not just for games. There's an awful lot of other industries, particularly in those situations where you need to keep things clean. Air gestures make a heck of a lot of sense. Okay. Towards the bottom of page 299, they talk about voice input. So you can hear me right now, right? That must be because I have a microphone. Okay, that's kind of simple. Voice recognition, on the other hand, is kind of sort of still in its infancy. Sure, I mean, there's been products out there for the Apple and PC. There's one called Dragon, Naturally Speaking. You've probably seen television commercials. And the idea is that it can operate practically everything on your machine. You can say, open Microsoft Word, and you can dictate and do all sorts of stuff. And it's getting progressively better. Smartphones have had some sort of voice recognition systems for quite some time. They're kind of prevalent now in cars. And once again, they don't want you to leave focus. They don't want your hands to come off the steering wheel. They don't want you to look over to something to be able to make, change the channel on the radio or that kind of stuff. So voice recognition is, again, kind of a safety kind of a feature in that regard. And again, it's getting better and better. So you have Siri and you have all the rest of the clones of that for the three major phones that allow you to talk and ask questions and get answers. We're not quite to the HAL 9000 from 2001: A Space Odyssey, but we're getting there. We're getting close. So again, the definition on page 300 is audio input is the processing and entering of sound. Yeah, okay. And not necessarily sound, not just speech. I mean, you could record sound effects and things of that nature. And if you're a sound recorder, producer, you record an entire band and all the instruments and everything, and then you mix them all together and, of course, produce an album or whatever. So voice input is kind of a special part of audio input. Next, on 301, they talk about video input. Gee, you think maybe we're doing a video now? Yeah, I have a video camera. So I'm recording digital video. And they make a distinction of digital video because that's kind of the way they think. But once again, if you were to go to a high-end kind of a store and say, I want to get a video camera, then without even asking, they know that you're talking about a digital video camera, because the analog video cameras are long since gone, unless you're Hollywood and you're producing a movie. In fact, even Hollywood now, there's lots of major movies that are produced completely digital. There's no film involved whatsoever in the production. Pretty cool. So digital video, DV. And they talk about webcam. That's what I have. I have a little camera stuck up on top of my monitor pointing at my pretty little face. And so it allows me to, record who I am. And if I'm doing video teleconferencing, I can have a little picture of of whomever, and can wave to them, and we carry on conversation. So let's just talk about some of the features on page 302. They talk about have some sort of a webcam. It could be built in. That little dot right there on the screen of this computer is probably a web camera that's built into the laptop. Probably. If you didn't have one, you'd have one of these little guys, which is what I have. I have one of these little guys just bolted onto the top of the monitor. Okay. So, you can do it for capturing still images and videos, sending messages, with video attachments, broadcasting live over the internet, conducting video teleconferences, and making video calls. And so if I had Skype running, I could just make an honest-to-God real, video call with audio and all, and so kind of cool. Which brings us to page 303, talking about video teleconferencing. It's kind of big business now. In the old days, you had these little business trips, and everybody would run off to Las Vegas, and they'd party and drink and have a good time. And oh yeah, by the way, we also met with the client. Those days are kind of sort of gone. And so now when you come time to meet for the client, typically you do a video teleconference where everyone's in the room, because there's a giant screen and they're on the other side of the world. Of course, there are problems with that, and time zone being the major one. If I've got a plant in Sacramento, California, and Germany, and one in Japan, what time of day should I have my video teleconference if I want all three of those people to be able to get on at the same time? A little tough, isn't it? Yeah. Otherwise, somebody's going to be losing some sleep. So video teleconferencing, pretty cool. The next thing to talk about is scanners and reading. Now, the book talks about flatbed scanners, and you used to be able to go and buy this thing. You'd go into the store, and say, I want a flatbed scanner, and they would say, sure, and they would hand you this thing, and it would plug into a USB port or sometimes some other type of port. And just like a Xerox machine, and you put the page down, face down, you push a little button, and out came a scanned version of your document. Now, nowadays, that's kind of hard to find. Typically, what happens now is you go and you buy one of these all-in-one things. So I just went to the HP product lineup here, and so they're selling a handful of printers. And let's look at the functions. It prints, it copies, it scans, it faxes, and does something on the web. Print, copy, scan, photo, web. Print, copy, scan, fax. So basically, when you buy a printer now, it is likely that you would have an option of buying just a naked printer and that's all it does, or buying a printer that had a scanning capability and faxing capability and all these other kind of things, all bundled together and all in one. So again, today, I would not recommend you go buy a flatbed scanner. You would get the same functionality by just going to your favorite retailer and buying an all-in-one printer that does everything. Okay, so the idea is that you connect these guys up, and instead of just being able to print, I can also generate scanned documents. Mine can scan to a graphics format like a JPEG file, or can scan documents directly to a PDF file, things of that nature. Okay, on page 304 and through to 305, they talk about the optical readers. And so you kind of probably know what we're talking about. There's optical character recognition. I could take, for example, a printed document. Let's say I had a page out of a book. I could put it on my scanner, and this machine will scan that, and then it could go through and read the characters and turn that into an electronic version. So I can edit the document in Word. A scanned version of a page, I can't edit. Well, I can edit it with, Photoshop, but I can't, go in there and change a word or add something or move a line down because it's not a Word document. But again, my scanner has the ability to take a printed page, stick it on there, and then produce a Word document at the other end that I can go in and automatically tweak. Now, is it perfect? No. What is, if you have a really, really clean, no coffee stains or anything, really, really clean original that had a very consistent, font, no changes in font sizes and styles. Generally speaking, I get about 2 or 3 errors per page. And now, if it's not ideal, I get 2 or 3 errors per paragraph. So, yeah, the technology's kind of sort of there. Now, don't get me wrong, it's better than retyping it from scratch. So, hey, I'll take 1 or 2% error rate in words as long as I don't have to type the dang thing over a second time. Okay. The other one is called an optical mark reader. You've probably heard this term. In fact, the university uses a brand name when they talk about it. They talk about Scantron. And, you have you've seen those little goofy forms where you have you take your number 2 pencil and you fill in a little oval. And so it's not doing character reading. It's not reading the character E and saying, ooh, that looks like an E. Instead, it's just using these little ovals, whichever one you have filled in, and it's going to read your form. So optical mark reading is pretty doggone good. I mean, the error rate is very low, unlike optical character recognition. Okay, on page 305, they continue with different types of scanners. Everyone's been to the grocery store and had a barcode read, right? Now, barcodes are physically about kind of sort of large. They're all about the same size. They're about an inch wide and sometimes about an inch and a quarter or so, inch tall and about an inch or a quarter or so wide. And the idea is that you could run these things through a scanner at a relatively high speed. In other words, you don't have to hold the can of peas over the scanner when you're at the grocery store. They just zip past, right? Boom, boom, boom. So the size and shape of this thing was kind of designed to make it go through, rather rapidly. Now there's new ones out there, and we've talked about this one. The QR, the Quick Response Code, QR code, is this 2-dimensional barcode, and it's not designed to be run through at high speed, but you don't necessarily need to. It's one where you've got a billboard or you got a magazine and you pull out your phone and you pop it with your phone and it scans it all and then launches whatever application or does whatever the barcode is supposed to do. So again, the traditional UPC barcodes for grocery stores was designed for kind of high speed, don't have to stop. And then the QR codes were really kind of designed for stationary or near stationary. You take a single shot, boom, with your camera, and you analyze that image after the fact. Okay, so it works pretty cool. Some other types of devices on page 306, they talk about radio frequency ID tag, RFID. And there's a cool technology. One of the ones I think is pretty cool. You know how a lot of companies have a policy that say, if you step away from your machine, you have to lock your screen, so people can't come into your office and see what you're up to. Well, there's a really cool feature that I kind of like. Is they'll have this thing that you hang around your neck, like your ID badge. If you have a company that requires you to have an ID badge, there'll be a small RFID tag inside your ID, and then you would have a device on the computer. And so if you step back, you're far enough away, and it puts your machine to sleep because you've stepped away from the computer. Pretty cool, huh? All right, so a lot of it's used for security, and you've probably seen all these cool things on television, where they walk up with a card and they swipe the card over something. Well, that's generally an RFID card and a thing at the door to let the secret agent in is the RFID reader. There's 2 different kinds of RFID. There's one called passive. For example, the kind that you have for theft prevention at a retail store, those are passive. The little stickers, you've seen them. And there's no battery in that thing. It's just stuck onto your merchandise. And if you walk past these big loop things at the entrance to the store, it senses, hey, you've got a tag there and sets off the alarms. That's a passive RFID. Active are the ones that actually have a battery inside and can send signals on their own. Kind of cool. Okay, so this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.